Hi, this is our final output for T-ECT311La, and we are the group Castaways, composed of Bryan Bautista, Denmike Mapa, and Cepe. So for the objectives of our final output, to design and simulate AM transmitter and receiver circuit. So for the discussion, we will now proceed for the multisystem oscillator circuit design diagram. So Colpitt's oscillator was used in the design. So Colpitt's oscillator can generate sinusoidal signals of very high frequency. So the Colpitt oscillator uses a capacitive voltage divider network as its feedback source. So the two capacitors, namely as C1 and C2, are placed across a single common inductor. So for the computation of the tank circuit, you can see here two types of formula. So FC is equal to 1 over 2 pi square root of LCT, and CT is equals to C1 times C2 over C1 plus C2. So you can see here that 660K AZ is equals to 1 over 2 pi 55 UHCT, and the value of CT is equals to 1.05 nanofarad. So for the modulator and power amplifier design diagram, so the modulator and the power amplifier are designed as a Class C amplifier. So with the addition of tuned circuit. So a Class C power amplifier active components such as transistors conducts for less than 1/2 cycle of the input signal. So a conduction angle of less than 1/2 cycle is less than 180 degrees with a usual range of around 80 degrees to 120 degrees. So the theoretical maximum efficiency of a Class C amplifier is around 90%. So with that being said, this enhances efficiency to a significant amount, but it also causes a lot of distortion. Due to significant levels of distortion, Class C designs are not employed in audio applications. So this is the design of a full AM transmitter. So this is the design of diode detector. So to remove the radio frequency carrier from the signal, a simple diode detector such as this, consisting of a diode, a resistor, and a capacitor can be employed. So the incoming signal is rectified by diode, which allows only half of the alternating waveform to pass through it. So the capacitor removes the remaining audio frequency signal components, while the resistor allows the capacitor to discharge, resulting in a smooth output. So this is the design for amplifier design in multisystem. And this is the AM receiver circuit. And as you can see now in this PowerPoint, this is what it looks like for the full AM transmitter and receiver circuit. So to identify the AM transmitter and receiver circuit, the first half of it going to the left, starting from the 1N4148 going left, that is the AM transmitter, while going right, starting again from 1N4148 going right, that's the receiver circuit. So we will now proceed for the last part of our report, which is the simulation part. Or rather, the way we will now show you the waveform results. So for the waveform results, you can see the first one is the output of the oscillator. And the next one is the output of the transmitter. And lastly, the waveform output of the full circuit design, which is the AM transmitter receiver output. We will now show you the simulation of the full AM and receiver circuit. So, as you can see here in our function generator, we have set the frequency to 3000 Hertz. So with that being said, by inputting 3000 Hz in our frequency generator as input, we can have a full good waveform that will transfer messages good. So for the oscilloscope, you can now see that this is our final output waveform. You can also see that the time base is set to 200 microsecond per division, while channel A and channel B is set to 5 volts per division. So the finished circuit output is successful because the waveform is comparable to the modulating signal despite minor aberration. So the output signal is 100 degrees out of phase with the input signal, but it really doesn't matter if this type of waveform output is 180 degrees out of phase, because it does not prevent the message signal from being reduced. So that's all. Thank you. And once again, we are Group Castaway.